My presentation topic is the effects of cognitive performance and in-class physical activity in physical education. First of all, I think I am really lucky because the data have been collected during the Science of Health for Living project, which was from 2011 to 2017. So before the pandemic, I already have my dataset ready. I analyzed the data in last May, wrote an abstract and submitted to the research program of the 2021 Shape American Annual Conference in last June and got accepted for oral presentation. As we all know, one primary goal of physical education is to educate K-12 students for lifetime physical activity. To achieve this goal, Shape America has identified learning health-related fitness knowledge as one of the learning standards. Some researchers, such as Alice, also brought learning health-related fitness knowledge to the Center for Physical Education. Research findings also found the positive role that knowledge plays in fostering students' physical activity behavior. The most researched cognitive learning strategies in teaching knowledge in physical education are those based on constructivist learning theory, framework of uh, framework theory of conceptual change. Specifically, the constructivist learning theory proposes the knowledge is actively accessed and constructed by the learner through building new knowledge on a foundation of previous learned knowledge and social interaction. The framework theory of conceptual change emphasized the importance of understanding the mechanisms of learning from the knowledge construction perspective. These two theories highlighted the importance of acquires the learning process and the methods used to promote knowledge acquisition. Cognitive load theory has been viewed as a unique extension of the constructivist learning theory and the framework theory of conceptual change. Cognitive load theory can serve as a conceptual guide for curriculum development and instructional planning, which focuses on issues of effective teaching, such as what learning materials or tasks can be processed by the learner in the most effective way, or in what way cognitive knowledge and physical activity tasks can be integrated seamlessly to provide optimal learning experiences. Cognitive load theory explains cognitive efforts' impact on learning behavior. Cognitive load theory proposed two types of cognitive load, which are intrinsic cognitive load and extrinsic cognitive load. In this study, I was focusing on the intrinsic cognitive load, which refers a healthy load that facilitates learning. Intrinsic cognitive load is determined by the connections among the knowledge components to be learned, which called element interactivity. The appropriate element interactivity is necessary for learning to take place. The element interactivity is often determined by the nature of cognitive learning tasks. As we can see in this concept map, two types of element interactivities have been identified. One is called high element interactivity. Another is called low element interactivity. In this study, the dependent variables, which are three cognitive learning tasks, descriptive learning tasks, relational learning tasks, and reasoning learning tasks, were categorized into either high element interactivity or low element interactivities group. In the Science of Health for Living curriculum, the descriptive tasks ask students to work on factual information, such as physiological responses they experienced during physical activity. The relational tasks require the students to relate their physiological responses to specific characteristics of physical activity and to establish the relationship between different concepts. The reasoning tasks lead students to understand the reason why their physical activities benefited their health, with specific connection between their behavior in the lessons with the health benefits and the consequences of physical activity or inactivity. It has been identified in the previous study that relational and reasoning tasks contributed directly and significantly to students' knowledge acquisition. However, few studies examine the effects of 3 cognitive learning tasks on students' in-class physical activity. And this is going to be the purpose of this study. The purpose of this study is to determine the extent to which cognitive learning tasks impact students' in-class physical activity. Although there are 2 units in the Science of Healthful Living curriculum, in this study, I only analyzed the data in 1 unit, which is Cardio Fitness Club unit. The participants were 115 students, came from 10 middle schools who completed all workbook assignments. As I introduced earlier, the intrinsic cognitive loads were measured using descriptive, relational, and reasoning tasks. In-class physical activity levels were measured by caloric expenditures. These pictures showed how workbook and cognitive assignments looks like. The anti-graphic accelerometer has been used to collect in-class physical activity data. At the beginning of the semester, the research team need to teach students how to wear the accelerometer and measure their demographic information such as weight, height, and age. So each student will have their individual physical activity data. The independent variable is in-class physical activity levels, and the dependent variables are 3 cognitive tasks. The relationships between descriptive tasks, relational tasks, and reasoning tasks were examined using Pearson's correlation analysis. And a multiple regression analysis were conducted to determine the impact of the intrinsic cognitive loads on in-class physical activity. Move to the result section. Pearson's correlation analysis demonstrated that positive significant associations among descriptive tasks, relational tasks, and reasoning tasks were moderate to large. We can see our range is from 0.57 to 0.75. A multiple regression analysis showed that the overall regression model was significant. Reasoning tasks directly and positively predicted students' in-class physical activity, while descriptive learning tasks and relational learning tasks were not significant predictors. The results appear to suggest that students' performance in reasoning tasks positively influenced their in-class physical activity. The correlation results suggested that 3 cognitive learning tasks should be collectively addressed in the physical education. Therefore, physical education teachers and curriculum designers should offer descriptive and relational cognitive learning tasks through effective instruction to enhance students' learning in reasoning tasks. In this study, the reasoning tasks with high element interactivity required more time and effort for the students to understand. But the students seemed to be able to develop cognitive schemas that incorporate the interacting elements and act on the understanding immediately in the physical activity setting to receive health benefits. Since this is a very first research, I would suggest that future studies are needed to future investigate the role of intrinsic cognitive load and task element interactivity on physical activity levels. Thanks to summer research assistantship funded me to do this study. Feel free to ask me any questions if you have. Thank you.